So the last time, I think what we did was 2017 with the NEC, and this time I'm focusing more on 2020, except the slides are pretty much the same. I even have some 2023 slides in there. It's always neat to know about the future. And usually most of the changes in the NEC are just organizational. They clarify things a little bit more, so they're not really changing things. And then for the IRC, the International Residential Code, and the building codes, I think we skipped quite a bit. I think we were even on the 2015. Does that sound right? The 2015. So there's 3-year cycles. So 2015, we skipped 2018, and now we're on 2021. So that's what we're looking at right now. And this is just some information about me. You also will get NAVCEP credit for this class. I can make certificates of completion for everybody. Just need to get a list of everyone. So I'm going to skip through a lot of this stuff at the beginning. One of the things that's kind of interesting, though, is the cover of the NEC has the sun on it for the 2020, PV for the 2017. Then I was looking at this one, and I heard that this is inverter noise. And we see these little dots there, but we'll see if that's right. And so you've all seen these slides, and the APS, Arizona Public Service, had a big famous fire. And the thing is with these container batteries is I think it's the best way to do it, but we just have to educate the firefighters. If there's no babies inside the building, don't go inside of it if it's smoldering. And yet the worst case scenario is you lose a container load of battery equipment, which is not good, but they went inside of it and it exploded and it would cause some serious injuries. And I think that if they didn't get hurt by doing that, it wouldn't be so famous. You can see 3 different reports written by 3 different people. And, there's LG Chem. One of the things that, fires get in the news, especially when it's a new technology, but it's so much less dangerous than gasoline in your garage. So all these different energy storage technologies, we're going to focus on lithium ion, and there's some lithium ion battery cells. And one of the things that we're going to talk a lot about is the energy storage system, which so far UL 9540 energy storage systems, that's what we'll be using. That's what it tells us to use in the codes, are things that are come out alternating current. There's no DC listed energy storage system yet that I know of. This is the Powerwall, which is, it's AC coupled. Tesla and Enphase have an AC coupled one, which means that in the same box, well, in this instance, in the same box, you have inverters and batteries. So you don't see anything DC. There's no way to even write down the DC voltage. What would you do? Take it apart, start counting cells? You get in trouble for doing that. So here is energy storage with a battery. This is also a solution right here that you can do AC coupling with. That's the LG, that's the SMA. And you can see that it's connected with some conduit right there. So it's a separate thing, but it still could be AC coupled. And we'll talk a little bit about AC coupling. I think probably, especially since you were here before, you know about that. There's a power pack. One thing that's kind of interesting is I have a 2015 Tesla Model S, and they have a megawatt hour power pack by one of the charging stations that I go to, which is kind of neat. So when everybody wants to charge all at once, they can go off of the battery. And just we see some other things here. Lithium ion, if it catches on fire, you can use water. So lithium metal is something that we don't really see. Like there's no 9540 listed lithium metal battery. You do have lithium metal batteries that are not rechargeable, but they haven't figured out how to safely recharge lithium metal batteries. And when they do, that'll be great because they can carry more energy per weight. That's called specific energy. Energy density is energy per volume. And in the meantime, with the lithium ion batteries, you can keep them cool by spraying water on them and they don't explode. If you had a raw piece of lithium, like pure lithium, and you got it wet, it would be very explosive. I've seen that happen before. Just when I was in high school, some welder was showing me a trick, how to make a big firecracker. So other things about energy storage, power times time is energy. A lot of times though, when they're talking about energy storage, they talk about capacity when they're connecting to the grid and they're giving those in units of power. But if we're talking about individual batteries, the capacity is usually given to you in amp hours. Most of the things that we're dealing with these energy storage systems, we're not needing to even deal with amp hours now because it's a listed energy storage system and you don't know what the amp hours are. Even like the LG batteries that people are installing, they're coming out of the, what you call the battery as DC coupled. So they are already direct current with a DC to DC converter, I should say. So they're coming out at a different voltage than the battery voltage. So you wouldn't even know the amp hours for something like that. Power times time is energy, all that kind of stuff. So generator capacity is usually specified in power, battery capacity, amp hours. It's really important to know the difference between energy and power. Power is a rate, power times time is energy, and it's not kilowatts per hour, it's kilowatt hours. Another thing that's kind of interesting, and it's almost not fair, is right now there is no UL 9540 listed lead acid battery. And so if you wanted to be really strict, you could tell somebody that they can't install lead acid batteries in their house, because if you want to install something in your house, it needs to be listed to UL 9540. So one of the benefits of the lead acid battery is it works better when it's below freezing. Lithium ion batteries, they would have to be able to heat it, and you can't really charge the cells when they're below freezing. Lithium is non-toxic, lead is toxic. Just some of the different metals that we're looking at. And like I said, I covered it before, so I'm just going to kind of skip through this part, except LFP, lithium iron phosphate, is a type of a lithium ion battery, and it weighs more than the NMC and the NCA batteries. NMC and NCA are the ones that they're mostly putting in cars. However, if you get the short range Tesla Model 3, like my girlfriend just got, it's got an LFP battery in it. So it's getting to be more popular with LFP because it doesn't use cobalt. It's better for the environment. Iron is, I think by weight, there's more iron on this planet than anything because the core of the earth is iron mostly. It's just really deep, but iron is very easy to get. There's lots of it. Phosphorus, easy to get. So the LFP batteries, they're heavier is the problem. But if you want to go a long distance in your car, you have the lithium nickel manganese cobalt oxide or the lithium nickel cobalt aluminum oxide. The NCA is more popular with Tesla. The NMC is more popular with the other vehicle manufacturers. But just remember too, these are all lithium ion batteries. Some people get mixed up and they think that lithium iron is not lithium ion. And then Fe is the symbol for iron on the periodic table of elements. So that's why we sometimes see it called LiFePO and things like that. And we're using secondary batteries, and that means they're rechargeable. So we have a lithium metal anode is what that is. And so these are the cathode materials that we're talking about here with the NMC, NCA, and the LFP. And I think more and more often you're seeing LFP for the stationary batteries. And it just makes sense because if it takes up a little bit more space and weighs a little bit more, it's not that big of a deal compared to if you're in a car. The big deal with being in a vehicle is you want it to be super light, because the heavier your battery is, then you can't go as far because your car is too heavy. And so specific energy is energy per weight, and that's the important one. Energy density is energy per volume. But usually when people say energy density, they mean specific energy. Even the battery companies, it's really common to see that. Here's just some different specifications. The typical lithium ion battery is each battery cell is 3.6 volts. But when you're talking about lithium iron, it's 3.2. Lithium iron is also a little bit more stable. Doesn't need as much in the way of a battery management system. And we can see that the prices of batteries are going down faster than anybody ever expects. And that's kind of the same thing with what happened with solar PV. However, we do have this supply chain problem that I'm sure everybody's familiar with. And so they can't make the batteries fast enough, which artificially brings up the price more, but also brings up the profit margins. Nickel iron was a neat technology. And nickel iron, the big benefit with this one is it pretty much lasts forever. They say that you can find an old nickel iron battery in a dump that's been sitting there for 30 years, charge it up, and it will work like new. But the problem with it, as you can see here, is it's really expensive and it's heavy and all that. That's why we don't see it much. There it is, lithium, the lightest metal. It's actually the third element on the third planet. It's very special. Cobalt, very controversial. Half the cobalt in the world is in the Democratic Republic of Congo, which is probably not so democratic. And there's a lot of child labor going on there. So if you need a place to send your kids for the summer, you can make them do some work for you. So lithium iron phosphate, it's got more thermal stability. It's more tolerant to a full charge. For instance, my car has the NCA, so that's a lithium nickel cobalt aluminum oxide, and I only charge it to 80% on a regular basis. And my girlfriend's car, she has the lithium iron phosphate. They tell her to charge it fully to 100%. And there's even some similarities. A lot of times you'll see some of these lithium ion battery companies, so their battery might be used with an inverter to make an energy storage system. So they would have to be listed together as a system to 9540. And so like Simplify or something like that. And using the Simplify battery with an inverter, that would be listed as a unit. But a lot of times they talk about 48 volt systems and things like that. And it's not really 48 volts nominal when you're using the lithium iron phosphate. And so what they're doing is it's 3.2 volts per cell, and 4 in series would be 12 volts is what they call it. And it's just kind of a naming system because it's close to that lead acid, but really it would be more than that. And then you would quadruple all this. If somebody says 48 volts, that's what they mean. It would be 16 of these lithium iron phosphate batteries in series. So different types of battery cells: cylindrical, prismatic, and pouch. And then we have cells, modules, and packs. Just like with solar, we have solar cells, solar modules, and solar P for panels, except they took panel out of the 2020 National Electrical Code. So we can't say solar panel anymore, or maybe we can, depends on who you're talking to. And so we talked about specific energy, energy density. This is a big lithium iron phosphate battery that I saw, and it was in Qatar. And when Qatar got the World Cup, that's the football or soccer match that's just going on next month, they were going to build all this solar to air condition everything. But then once they got it, they backed out on the solar part. So they got it, and then they backed out on the solar part. And Chevron hired me to come over there and do some talk with their engineers. One of the neatest things I've done recently is I went to Masdar Institute in Abu Dhabi this year, and I saw a couple of gigawatts and did a week-long advanced training. So we're just looking at some of these different things. And so when it says hybrid, it's not an NEC definition of hybrid, but what they're doing is they're connecting PV and a battery into the same inverter, or let's just call it an inverter for right now. There we go. There's the in-phase AC coupled one, LG Chem. There, I did EV to grid 2 years ago. So I could say that I was the first, and it actually would void the warranty of the car. There's the EV1 that you've probably heard of. There's forced labor going on in China, which is controversial. And there's plenty of lithium in the world. Some people will worry about the lithium. It's not the lithium that's the problem, it's the cobalt. We can make an electric vehicle for every person on the planet if we used up our lithium reserves. But still, with supply chain issues, they can't ramp up things as fast as they want. But there is lithium that we can find. If you do have battery cells, they can short out and they can make a big spark. And so this is somebody who was injured. Okay, so now we're getting more into the code. 1984, NEC was the first one that had Article 690. And the earlier versions, up until they came up with Article 706, included actually more batteries in 690 than it did in 480. And then they took the battery part out of 690 and they made it its own separate Article 706. There's the 1897 National Electrical Code, which is kind of neat. Some battery stuff in there. This is what I've been working on a lot, is the 2023 NEC version. The 2023 NEC was released just over a month ago. And so every morning I wake up early and I work for hours undisturbed. I'm on up to chapter 9 right now. So here's some other books that I have. And then if you want to get a great copy of the 2017 NEC, but we're on the 2020 now. But anyway, if you search for Tool Texas, you get that. You can also see free NEC at nfpa.org. I'm using NFPA link to use for the 2023 NEC. But once something is law, then it's not illegal to distribute it. In the last year or so, there's this organization called Upcodes, and there's their link, and it is great. I use it constantly. I can't use the 2023 NEC there until Massachusetts adopts it on January 1st, but it's really good. And there's a free version and there's a paid version. One of the things that I'm doing for the 2020 NEC is I go to the Minnesota one because they adopt it without amendments. So I'm just looking at the plain old 2020 NEC, because with upcodes, they have to show you what's been adopted in different places. You can see also this presentation, the links are clickable, so it can take you there. There's 2023 NEC. And so in this presentation, I'll have a couple of 2023 NEC slides, and it'll have this red, I'll put this there so you're not confused, but just don't get overly concerned about having the wrong version of the NEC, because like I said before, most of the changes are organizational. They don't change what you do. Massachusetts, like I said, adopts it right away. And it's sometimes funny when they came out. This was January 2014. And if you remember, they had the 2014 rapid shutdown where it was 10 feet from the array. And so they put this disconnect 10 feet from the array. In fact, the inspector told them to do that. They were just, what do we do? I have a lot of resources on my website. And so here's NEC adoption lists and maps. So I link to all different, adoption lists so you can see what's going on there. And then I always want to point out the worst state for solar to give them a hard time. We have North Dakota, which is 52 out of 50. That's their ranking, 52nd. So, of course, you have DC and Puerto Rico ahead of them. There's solar in 41 houses. And so here we're looking at the way the National Electrical Code is organized. So 1 through 4, chapters 1 through 4 are for general installations. That means they apply to everything unless chapters 5 through 7, which mostly we're going to be focusing on, supplements or modifies it. And so if we have something different in 706, it supersedes 480 because 480 is in chapter 4. So there's a lot of different reasons why we should be using Article 706 for energy storage and not using Article 480. There's also a standard, and I don't know of no place that has adopted this NFPA standard. The NEC is the most widely adopted code, but there's lots of different standards. It's NFPA, you can see all their standards. It looks to me like a list of 1,000. I'm not sure if it's exactly 1,000, but there are a lot of standards that NFPA has. This is 855. NFPA 1 is the fire code that competes with the IFC, the International Fire Code. And I know I think it's like Florida and Maine and a couple other places that have adopted the fire code. But anyway, you can get some good ideas from 855, but it's not something that's usually enforced anywhere except maybe by an insurance company. So a code tells you what to do and a standard kind of tells you how to do it. That's the difference. So standards are more like best practices. Codes are like, if you don't do this, you're breaking the law. So here's a lot of different energy storage uses. We could have a whole class about this, but we're just going to skip over it for right now. But it's not just storing energy for long periods of time. There's lots of ways where we can help out the grid and condition the power with energy storage. So here's AC coupling. The way that I look at AC coupling is that to charge the battery, you have to convert to AC first, and that's called AC coupling. And of course, too, you only have AC coupling when you are coupling things together, like coupling PV and energy storage together. And then you can have AC coupling, and you can have DC coupling. So this way you could charge the battery without converting to alternating current. And let's just go here. A hybrid is a type of DC coupling. And so it's sort of like you have a charge controller and an inverter in the same box. Kind of convenient. This is just a diagram from the NEC that you've probably seen a million times, but it kind of gives us an idea. The PV system disconnect is where you separate PV from any other system, such as energy storage or loads. So here, with a DC coupled system, your DC disconnect is going to be your PV system disconnect. Whereas with an AC coupled system, you have an interactive inverter. And so even when you get to this, your inverter is only there for PV. So then here is your PV system disconnect. There's an AC disconnect. There's the energy storage system. They did take these images in the 2023 NEC and they moved them to 705 and changed them around a bit. So there's some DC coupling. There's some AC coupling. You have an interactive inverter. You're tricking it into thinking that there's a grid or it's a microgrid with energy storage. And one of the things that we've been seeing more of lately is with these microgrid interconnect devices. And it's kind of neat. So we actually had this function inside of our multimodal inverter all the time, but we took that function out of the multimode inverter and we put it in a separate place. And it's kind of neat when you're doing AC coupling to have this. The microgrid interconnect device, though, has to be able to talk to this multi-mode inverter to tell it to go into standalone mode, to go into interactive mode, and all that. And so that's a microgrid interconnect device. It's sort of like an automatic transfer switch, but it has the ability to talk to this inverter to tell it what to do. And we don't call it an automatic transfer switch because the code has better benefits for us when we call it a microgrid interconnect device, or an MID. So here's different energy storage articles that we're going to do some talking about. We're not going to talk about 712. In fact, in 2023 NEC, they took 712 and they stuck it into 705 interconnections where AC microgrids were. But we are going to mostly talk about 706 today when we're talking about the code about energy storage systems. And so there's all these different reasons why you shouldn't go to 480. One of the easy ones is if you're doing a PV system, 690 tells you not to use 706 for energy storage. And it was the intention when they made Article 706 in 2017 NEC was to get rid of 480. And then at the last minute, the telecom people got them to keep 480 because telecom people don't want to have many rules. And so they will just go put a bunch of batteries there, even without DC disconnects and things like that. So here in 690, it says use 706. So 690 supersedes Articles 1 through 4 and modifies, supplements and modifies, and so does 706. All these different things direct us away from 480. So we don't need to really worry too much about 480. So let's get into 706. And so 706, the scope of 706, they say is for 1 kilowatt hour or greater. 2017 NEC, they were talking more about 50 volts or 60 volts. And it's funny because I'm in Tennessee, I'm doing an NEC presentation tomorrow on the 2017 NEC. And here's the 2023 NEC. So pretty much it's most of the changes, like I said, are organizational, but it's kind of neat to know things. This is just always interesting. There's Yoda, and I've seen them around for the last couple of years. And they make these 1 kilowatt hour batteries that go underneath the modules. So it's not only an inverter for the PV, it's an inverter for the battery, and it's a ballast for the ballasted system. But there are a lot of different things to break when you have all these distributed batteries. They even told me that they have a cooling system. It's kind of interesting that it's 1 kilowatt hour. It barely fits into the scope of 706, which is 1 kilowatt hour for the 2020 NEC and 2023 NEC. And I was like, well, shoot, you could have made it just like 1 watt hour less, and then you wouldn't have to follow that many rules. And so we always talk about nominal voltage. That's the naming voltage, like I said before. So with batteries, with PV, there's a range of voltages that they work through, and nominal is the naming voltage that we have. Something like your car battery, nominal voltage is 12 volts, but when it's sitting there fully charged, it's 12.6. When it's halfway dead, it's 12 volts. And then this is showing how the NEC contradicts itself. It says a battery storing energy is not necessarily an ESS. An ESS can be comprised of batteries storing energy. So it's just, you could sit there all day going like, this doesn't make sense at all. And that's the case. So it's a subtle distinction. So what we're looking for is 9540. Pretty much all of our 9540 energy storage systems have 1973 batteries, and that would cover the lithium-ion batteries. So just by being 9540, it means that it's also 1973, unless somebody comes up with a lead-acid one, and then it would be using this one at the bottom, number 7. And so here's 9540. You can go read that for free at the UL website. You just have to put in a lot of passwords and things like that. And it's really boring. This is something that's called the 9540A test method. There's a lot of confusion about this. And so we're going to talk about this more as we get into the code. But if you wanted to do something that is outside of the scope, like let's just say that you have 2 Tesla Powerwalls, and you want to stack them like this Tesla tells you you can do. You can put two right next to each other, right up against each other if you install them that certain way. And that's because Tesla went through the 9540A test while you had two next to each other that way. Otherwise, you wouldn't have to follow the 9540A, but you would have to keep the batteries 3 feet apart. And so we're going to look at all that kind of stuff coming up. We need to move fast forward because we only have so much time for all that. Energy storage system, one or more components assembled together capable of storing energy and providing electrical energy into the premises wiring system or an electric power and production and distribution network. And so pretty much nobody's going to go out there and get a DC energy storage system listed because there's no demand for a DC premises wiring system. So let's see, let me just kind of get past some of this stuff. Flow batteries, you're probably not using these. There's a lot of battery technologies that are talked about more than they're used. And I'm out every day, I get somebody going, this is the way of the future. And we'll see about that. Inverter utilization output circuit. So it's between the inverter and the utilization equipment. So it'd be like for a standalone inverter. Here is just some of the things, energy storage system. That was some of the questions that was about labeling and things like that. And so a lot of this stuff, these requirements too, are things that you're going to get on the label of the energy storage system itself. So this is a Powerwall label, and it's going to have a lot of stuff like that, the manufacturer's name, frequency, and all that. Fault current is kind of silly when you're coming out of an inverter or a DC to DC converter, because the fault current is going to be very close to the operating current. They kind of put that in there, I think, by mistake, because they are looking at, our old lead acid batteries, where if you cross positive and negative, you can have explosive amount of fault current. But anyway, you would just get all this information from the manufacturer. So output current, voltage, all this stuff is kind of obvious, and it should just be on the label. A lot of this stuff too is just, it's part of the listing when they go through 9540. Some of the things that they're checking for is what's on the label, what it says on the label. We don't have to calculate amp hours listed. We know about that. You can do a search for OSHA, NRTL, and so the UL, CSA, a lot of different organizations that can do the listing. And so there's 9540. We talked about that. Sometimes we call that an umbrella because under that umbrella is the 1973. And so the 9540 is for a system, energy storage system. And so that system is going to have an inverter and a battery. And sometimes they're of different brands. There we go. We can have multiple energy storage systems. Somebody has 10 of them right there. That's a lot. That's more than my car. Probably costs more than my car too. I'm sure it does. So one of the things about the NEC is it's not a maintenance code. We can look to the IRC. And so it's actually a mistake that they put this in the NEC because the NEC is not a maintenance code. However, they want to see written record, and that's also going to be in the IRC of, maintenance and things like that. So storage batteries, like I said before, we're not doing 480 here. And the maximum voltage shall be the rated input and output voltages. So pretty much it's just kind of obvious. Maximum voltage is going to be what it says. And typically maximum voltage of an energy storage system is typically going to be AC. So we're looking at 240 or 480 volts, or it could, of course, 208, something like that. Disconnecting means. So we are going to talk about some of the stuff disconnecting means, and we're going to look into that a little bit. This is just kind of a summary of what's coming up, but we're going to have different types of disconnecting means too. We have the PV system disconnecting means, and that needs to be load break rated and things like that when we're talking about PV. But we also have equipment disconnecting means too. And so most of Article 706 is talking about the energy storage system disconnecting means. Let's see, we need disconnecting means shall be provided for all ungrounded conductors derived from an energy storage system and shall be permitted to be inside of the energy storage system. So let's kind of look over here. The disconnecting means needs to be readily accessible inside of the energy storage system and shall be lockable in the open position. Like just for instance, with the Tesla Powerwall, one thing that you have there, there's a button on it. And if they could lock that button, if that little button on the side of the Tesla Powerwall was lockable, then that could be the disconnecting means, just a little button. It doesn't have to be, some big, huge, high current rated, load break rated disconnector, anything like that. If that button would just turn off the inverter coming out of that Powerwall and be lockable, then that would work. For 1 and 2 family dwellings, you need to have the disconnecting means outside of the building, and we're going to look to and see how it can be also like a remote type of a thing. One of the things that people were having problems with is if you had the disconnecting means outside of the building and you were running all of your current through that disconnecting means, it's almost could make an extra danger because you have the conductors going from, say, your energy storage system to that disconnecting means still energized, but then you're shutting off all the loads and things coming out of it. So it's still some work to be done on this before we make it more like rapid shutdown or something like that. So remote actuation, now what we're talking about, where controls to activate the disconnecting means are used and are not located within sight of the system, the location of the control shall be marked on the disconnecting means. So if you're using remote controls that are not in sight of the system, then you mark it on the disconnect where the controls are. But typically you're going to be able to disconnect it in both places. And so here we have some disconnecting means. There's just a little on-off switch. I always thought this little I and O, how do you remember that? Because O is for off and O is for on. So I think of binary, ones and zeros. So 1 is on, 0 is off. That's my little trick for that one. So this one too, the notifications and markings. I know that's something that you're interested in, is the markings. And you go through this big long list, and then it says if you're doing residential 1 and 2 family dwellings, you only have to do number 1. So number 1 is the AC voltage. And a lot of times, like, you don't even have DC voltage. You could say perhaps that you do between the battery and the inverter. You might as well mark that there. The fault current, if you have something bigger than a 1 and 2 family dwellings, you would just have to get that from the manufacturer. And then also same would go with the arc flash label and the date the calculation was performed. A lot of this stuff sounds like 480 battery type of stuff too, where they probably took it out of there. The date calculation was performed. Like if you have a lead acid battery, over time, the short circuit current will get less as the battery wears out. I had a couple of people send me lists of questions. And so here is a famous sign that we see through all throughout all the renewable energy places. In the code, it's the one that says, warning electric shock hazard, terminals on line and load sides may be energized in the open position. And so if you might have electricity on both sides after you turn it off, then you would put this sign there. And one of the places that I've seen people put this sign where they don't need it, I guess it's not going to hurt if they put it there though, is on an AC side of an interactive inverter. So you have an inverter that goes to the grid. Inverters that go to the grid do anti-islanding so fast, it's faster than a human muscle can move and touch an energized wire. And so you don't need this on the AC side of an interactive inverter. But, between a battery, an inverter with a charger and things like that, or even a DC disconnect that even has rapid shutdown, you still might want to put it there, like even for, say, Solar Edge or something like that, because with rapid shutdown, 30 volts in 30 seconds, so up to 30 seconds, you could still get shocked. And so partitions between components, energy storage passed through a wall, a readily accessible disconnecting means shall be provided within sight of the component. And so this was another question that somebody was having. And so if we have these different components, it's not an energy storage system, but if you're going through a wall, then you would want to have a disconnect for each component. So this does have a switch on it, and I would consider that a disconnect going through a wall to here. The thing is, you can see just in this picture too, there's no code requirement to have a big, huge load break rated disconnect here. There could be a HJ requirement, or utility sometimes wants to see things on the DC side, which I really think the utility should focus on the AC side because that's what's going to affect them. And then you can have a DC disconnect over here on this side. So if a disconnect has multiple sources, then it should shut off all sources, not something super common. Maybe you could say this, if you're the solar edge store edge, you turn off that DC disconnect, it should shut off the battery and the PV. And that would be something in the listing too. So you wouldn't really have to worry too much about that because it's listed that way. Of course, things need to be listed as interactive if they're going to connect to the grid. Some of these things are just obvious. And unbalanced interconnections, I don't think there's much of a problem with that. Just like loads can be slightly unbalanced. You can have single phase loads on a 3-phase or split phase system. You can also have single phase interactive inverters on a 3-phase system. There's no rule against that. So let's take a look here. Other sources. So we're going to look at all this later, 705. We're going to skip over DC microgrids. It's pretty much all covered for AC microgrids too. And then standalone, there's a couple of things there that are kind of neat. Okay. Ventilation is for lead acid and NiCad. That's where when you overcharge these things, you get a flammable gas. In fact, even if you have a sealed lead acid battery, I know that some people writing the code say that if it's sealed, you don't even need the ventilation. I've always thought it's still a good idea because if you accidentally overcharge it, that you still might get some kind of gas, but some of these sealed batteries would be just not too flammable. But we're not really going to be seeing much in the way of lead acid, I don't think, anyway. And so we don't need the ventilation for the lithium ion batteries in general. Okay, so this is one of the more confusing parts of the code in Article 706, because it says an energy storage system shall not exceed 100 volts. And every 9540 listed energy storage system is 240 volts at least, or 120 volts even, because we're talking about AC. And then it says, unless during routine maintenance, live parts are not accessible, and then 600 volts shall be acceptable. I think that they just need to write this part of the code a little bit better. And so one of the things that you'll notice is when you see one of these energy storage systems, you don't go in there and do maintenance on the battery cells. You don't go in there and add a little bit of lithium when they start wearing out like you would with a lead acid battery, how you add distilled water. So here's a little bit about spaces between components. And this is just general, same for, other things too. If we go to 110.26, we usually, like your typical residential system, 3-foot depth, 30-foot width, or the width of the equipment, of course, and 6.5-foot height. And if somebody's over 6.5 feet tall, then they are already retired and make a good salary playing baseball and their basketball. They're not working with us anyway. So here's just some of those working space requirements. You're probably already familiar with all that with PV. Identification of power sources. So we have the labels in accordance that just tells us 110.21b, tells us how our labels, are recommended to be, weather resistant and not in handwriting and things like that. And so we need to have plaques. And so you're going to have a placard or a plaque or a directory that's going to show the firefighters that when they turn something off, that they make sure they get everything, if you have different disconnects in different places. So if you have all of your disconnects in one place, like it's all right by the meter and you have all your disconnects in one place, that's the best way. And you just need one plaque or directory, something that tells you, what to turn off. And if you have different things in different places, different sides of the buildings, then you need a plaque on different sides of the buildings. And then also when you have a standalone system, you're going to, of course, need to have some place outside where it's going to tell somebody where to turn it off, and that's going to be in 710. Wire sizing is much like the rest of the National Electrical Code. PV and the NEC also includes energy storage. That's the book that I'm working on right now. And there's chapter 12. I posted it on the internet, and it's really complicated, but that's the correct way to do wire sizing. And that works for all the things that we're doing here. So let's see, we have the nameplate rated currents and things like that. One of the things too is we use continuous currents, not surge currents, for wire sizing and things like that. And sometimes you're going to have a greater charge current or a greater discharge current, or same with voltage, and you use the greater of whatever it is. If it takes more voltage or current to charge a battery, then you use, of course, just obvious right there. And I just mentioned that too in the last one. Diversion loads, just not really common right now, but we oversize things for diversion loads. Sometimes you'll have a charge controller that when something is fully charged, you do something else. It's actually kind of common with wind. And like say that your batteries are charged, you're not connected to the grid, then you want to heat up some hot water, do something useful. That would be called a diversion load. With electrolytes and things like that, you need to identify the types of electrolytes, like vanadium is one of the types of electrolytes, prevent spills. This is kind of interesting. So this is where somebody is using some flow batteries. Nextracker, real common for utility scale. And they have some vanadium batteries, some flow batteries, and it's DC coupled, and they put it out there. So one of the benefits of these flow batteries is that you can discharge it to 0, charge it to 100%, and it doesn't affect the life of the battery at all. And so with lithium ion batteries and lead acid batteries, you can't do that. You can't go from 100 to 0 as often as you want, or it would reduce the life of your battery. So there's a single axis tracker. That's the most common type of utility scale system that there is. Nextracker is the big one too, the big company. So it's kind of neat. So flow batteries have some plumbing with electrolytes and things like that. It's a lot like a fuel cell. And if somebody's using a different type of energy storage, I think that is kind of neat, but it's not necessarily something that we're going to see. So I invented one. So we've got a flow battery that you lift it up, that's gravity energy storage, and then you spin it, you get some flywheel, and then you heat it up and you take that thermal energy out of it too. And so that's my patented system. I'd like you to join me. We can make millions doing this with this new type of a system. And I think that is about the end of 706. So standalone systems also was moved into its own article away from Article 690. And so there's a little bit about that.
There was a couple questions posted in the chat, and I know you can't see the chat. Do you mind if we just look at those real quick, or maybe I can state them? So one of the inspectors, Richard, asked, is an ESS required for a residential solar and battery PV system? And then there was a response from James Williamson. There are requirements for PV to have exterior disconnect, rapid shutdown. There are also requirements for ESS to have an exterior disconnect. And then there's a question associated with it. Does code require these to be the same disconnect switch, or can they be separate?
Yeah, so it sounds like the first question, somebody already answered it for me, so I have to share some of my feed with them. As far as they can be the same disconnect or they can be separate ones. And it's not really that clear. I mean, it's nicer, of course, that it's the same disconnect. And I think in future versions of the code, it will be more clear. But yeah, you can have it be the same. It could be different.
Right.
Yep.
Okay, those are the only two.
Yeah, so it's nice if just like the rapid shutdown switch does it all. I guess you could label it rapid shutdown switch and battery disconnect, energy storage disconnect, something like that. That would be a good one.
So is an emergency shutdown switch required to shut down everything? And can it be microprocessor controlled or mechanical?
Yeah, either way. Yep. Let me see if I could see where we were just talking about that. Okay, so let's see. So disconnecting means readily accessible in sight. This is kind of funny too. It says in sight, but if not practical, as close as possible, shall be lockable in the open position, 1 and 2 family dwellings outside of the building, and where controls to activate are used and not located within inside of the system, like outside that we were talking about, location shall be field marked on the disconnecting means. So if the disconnecting means is inside, it should tell you where you can turn it off. Like if you can't turn it off there, I would think that you should be able to turn it off in both places anyway. But if you have a remote disconnect, on the disconnect itself, it should say where the remote disconnect is. So like that could be inside the house. You could say like, oh, the disconnect switch is outside on the wall by the meter. So does that answer that question? You mark it on the disconnect where the controls are.
Yes.
And great. Okay. And so I remember this one guy that picked me up in New York, and he was listening to some class at 2 times the speed. And so I'll try to do that now. You see how in your podcasts and things, you could listen to him twice as fast. But actually, after seeing him do that, I started listening at 0.8 just so I could relax. So this is just a friend of mine's off-grid system that's not up to code. This is a system that I was first working on around late 90s. Solar Living Institute, they were powering things with bicycles. It's kind of neat. They went out of business. This is a little off-grid system on the Inca Trail. If you go hiking up to Machu Picchu, I recommend that. It's facing north. Okay, so here we got Article 710. They like to talk about island mode. And so island mode just pretty much means standalone. That's what island mode means, is it's operating without a grid. It's the opposite of interactive. And so we have islanding and anti-islanding. And so, of course, when you're operating in standalone mode, your things need to be listed. I also think that probably you're not even working on systems that are standalone, but when they have battery backup, they need to be able to comply with 710. So they need to be listed, of course, always. You want a permanent plaque, and we kind of talked about this, and we see this everywhere throughout the renewable energy parts of the code, 690, 710, 705. And if we're going to have different places to turn off different sources of power, then we're going to need a placard in every different place that shows where the firefighters can turn off all the different sources of power. So we have these different plaques, directories telling us where all these things are. And then also it should say on it, caution, multiple sources of power. And you could typically go to one of your places, like Hellerman Titan or PV Labels, and they're going to have all these plaques or directories that they can sell you with all the correct wording. So there we could see that one is coming, caution, multiple sources of power, and showing these different energy storage systems, rapid shutdown switches, and all that. Operating voltage, 240 volts. And so this was something for a Tesla Powerwall. And we have the different inverters, energy storage system disconnects, and all that. And one of the things that we've always seen when we talk about standalone systems is we're thinking about usually like old style, when you have a battery connected to an inverter. But if you're just connected to raw batteries with no DC to DC converters or anything like that, which we're pretty much not doing for these 9540 systems. However, whatever the lowest voltage is going to be the highest current. So voltage times current is power. And so the lower your voltage, the higher your current. And so you would adjust for that. That would be more like just a tricky test question that somebody would give you. You don't size wires based on surge currents. A lot of times the surge current can be double of what the continuous current. So you're always sizing your wires based on operating current, especially with like standalone systems. That's where you're going to have these available surge currents. Here's something else too that is kind of confusing for different people in different places, and it goes throughout different places of the code, is you don't need to be able to power all of your loads at once. You don't need to power the calculated load like most electricians do. You just need to have as much power as the largest load. And it says power supply. It doesn't say battery inverter or anything like that. So for instance, my brother has a system up in Alaska where it's got PV, an inverter, and a generator. And there's certain loads that he can only operate with the generator, and that's okay to do. And it would just be kind of stupid, that something wouldn't work if you had a 10 kilowatt load and only a 5 kilowatt inverter, because it would never turn on. It would just automatically, the reset button would come on, or maybe the surge could handle it for a second and then it would turn off. And so we don't need to supply the whole calculated load. If you have an automatic transfer switch in Article 702, there is some confusing parts about do you need to power the whole calculated load? And so that's one of the reasons why we don't call it an automatic transfer switch. When we're dealing with energy storage systems, we call it a microgrid interconnect device. We'll talk a little bit about that more if we have more time. So we size things on the continuous currents and just obvious things here. One of the things too that you see with standalone systems is a lot of times they'll be able to supply only 120 volt loads, and people will take a 120/240 equipment, bond line 1 to line 2, and then you could overload the neutral if you use a multi-wire branch circuit. So you have to have a sign that says single 120 volt supply, do not connect multi-wire branch circuits. And so that's just if you're using 120/240 equipment for a 120 volt system, which is kind of neat to be able to do. You just can't be using, multi-wire branch circuits, which means you would have some Romex or something that has line 1, line 2, neutral, and ground. and then line 1 and line 2, you'd add them together, and that would be how much current would be on the neutral instead of them canceling each other out when you are out of phase. Energy storage, not a requirement, so that's called direct PV there. And so backfed circuit breakers, if you're backfeeding a circuit breaker with a standalone inverter, it needs to be secured. It can't be a plug-in type of a breaker. And Article 625, I think, is very exciting, and I would plan on getting ready for this when, if people are installing their systems. Our cars are the best energy storage systems out there. They're the huge batteries. It's kind of funny how the car with the battery costs about the same amount as the energy storage system with the battery. And we have all these different requirements in different states to get a certain amount of new vehicles being electric, and 2030, 2035, things like that. And we're going to have bidirectional electric vehicles. The Ford F-150 seems to be the first. And so that's just pretty exciting seeing all this stuff happen. And so here, Ford F-150 powering the grid. And so it's actually really sending electricity back to the grid. Like my electric vehicle, out of the whole battery, I probably use on the average day 20% of it. Some people would say 80%, some people might say 40 or 60, depending deeply I want to cycle up and down my battery, that I could assist the grid with. And a lot of times the grid doesn't need a whole lot of energy, it just needs power for short periods of time. I think we're going to see a lot of that coming up in the future. And here is the bidirectional charger from Ford. And I think now that Ford is doing it, we're going to see in the next year, just my intuition, a lot of other companies doing it, especially if they can start building these cars as fast as people want to buy them. So we need to fix that supply chain, but there's a lot of these bidirectional things. Okay, so here is a presentation on the 2021 IRC. And so what is the scope of the IRC is essentially 1 and 2 family dwellings. And the International Building Code is for larger buildings. And the International Fire Code is sometimes called out and referenced by the IRC or even the International Building Code. But the International Fire Code doesn't just apply to the IRC without the IRC calling it out. And I think, too, that you're mostly interested in the IRC. And so this is what Bill and Neil sent me, was just some different things that the codes that you have adopted. So we're talking about the 2021 IRC here. We're also going to talk about the 2021 IFC. And then we've already talked about the 2020 National Electrical Code. So there's different places where you can get this. Upcodes is pretty good. One of the things, though, about upcodes, though, it's not updated to what you're using. They're really nice, too. If you sent them this link, they would probably go, oh, really? And then they would update the next day or so. They would have all the correct codes. Sometimes it's kind of hard to find, when they have 50 states to look at, or, 52, including District of Columbia and Puerto Rico. And also, by the way, this is not the IRC and the IFC logos that I'm using. This was for international ratings certification, but it was for sailing. So I just thought the logo looked neat, and I like to sail. So I took their logo. That way the IRC won't come after me. The IRC is published by the International Code Council, and I'm just kidding. I don't think they'd come after me for using their logo, but I just wanted to mix it up a little bit. So here's a great source. I know that you're inspectors, and I would imagine that you've probably seen this before. There's simplified permit guidelines for solar and storage. And so this is what you should probably be using here. The problem is sometimes we're seeing people spending $7,000 or $1 per watt for permitting. And that can get really frustrating. It's different in different AHJs, so it's nice when we can reduce those costs like that. I mean, if you look at it, $1 per watt, in some places in the world, they will install the whole PV system for $1 a watt. Like if you go to a place like the Philippines where there's cheap labor and cheap PV, and they don't care about the labor practices in China, they will install a residential PV system for $1 a watt. I do a lot of classes in the Philippines. They copy the National Electrical Code. And so here is the SolSmart permit process, and it's kind of new too. So there's a link for it. See, September, so just last month. And you can click on that. And Bill, he's my good friend that I co-write a book with, Bill Brooks, you probably heard of him. He's the one writing this commentary right here, the commentary, he wrote this. We did some presentations on this a year ago with his rough draft. And another thing too is the 2021 IRC does not contradict the 2018 IRC, but since you never even adopted the 2018, I guess it doesn't matter. So what they're telling people is if there's an AHJ that's using the 2018, they can use the 2021 and it won't be wrong. So here's just a little summary of the things that we're going to look at now. And so we've got, general equipment installation, spacing, locations, energy rating, electrical installation, fire detection, protection, ventilation, EV use, documenting and labeling. And in between here, what we have is I'm going to go off because the IRC points to the IFC, and then I have just about as many slides for the IFC as I do for the IRC here. So we got to comply with 9540, and if it's going to be residential, also energy storage shall comply with the provisions of this section, with the exception of, so if something is 9540 and marked for use in residential dwelling units, then you actually kind of don't have to follow even the IRC and all this stuff that we're talking about, which is kind of interesting. And then also you don't have to follow it with less than 1 kilowatt hour, same as what it says in the NEC. And also this one too, where it says if it's marked for use in residential dwelling units, you still have to follow the manufacturer's instructions and NFPA 70, that's the NEC. I kind of already mentioned some of that stuff. Here is 9540. We already kind of looked at that. That's UL 9540. And here's another interesting exception. Where approved, repurposed unlisted battery systems from electric vehicles are allowed to be installed outdoors or in detached sheds located not less than 5 feet from exterior walls, property lines, and public ways. It's sort of like a get out of jail free card for second life EV batteries. So when my battery gets down to 70% and I just want to put a new battery in it, I could take the old one and power my house with it, perhaps. And this is kind of showing me that I don't have to really follow a whole lot of rules if I do that. Just put it in a shed out back. So I thought that's kind of interesting. I'm not sure it's the safest thing. Installation, according to manufacturer's instructions, and that's with anything. We almost don't have to say that. And spacing. And so this is one of these things that the 9540A large scale fire testing, what I have in green, would make it so you don't have to do this spacing. I'm going to show some images on this too, separated from each other by 3 feet. That's what we're talking about. And so here's a little bit about that large scale fire testing. And it's a little bit controversial because the 9540A test is a pyromania test. It always catches fire, but they have to see at which point it catches fire where it won't propagate from one adjacent energy storage system cell to another. It won't just be like something that propagates. That's what we're interested in, is so like if one battery cell burns up, we kind of expect that that's going to happen at some point. And so if one cell burns up, we want to have that be under control so it doesn't just start a chain reaction and start catching the other cells next to it on fire. And so the 9540A test, it's also recommended to not look at it even as an AHJ, to like look at the specific test, because they always catch on fire. And if you look at it and they say, oh, you saw this, then you're just getting liability and more likely to get called into court. If something is listed and it's in the instructions and it's done the 9540A, you could just trust that testing lab that did it. So here's an example of 3 feet apart. If we had an inverter in between that was greater than a foot, and we had a space between the inverter and the energy storage system that was each a foot, according to their instructions, that would be one way of keeping these energy storage systems apart. And so here we're showing 2 different 20 kilowatt hour energy storage systems separated by an inverter. And once again, large scale fire testing could let it be. So like the Tesla Powerwall, you could stack 2 of these right on top of each other according to instructions. So individual units shall be separated by 3 feet, except where smaller distances are documented to be adequate based on 9540A, which is large scale fire testing. read that in the instructions. So that's just typical for the power wall. There's 3 in a stack right there. Those all each have their own inverters in them, of course. And so if we did the large scale fire testing, we're just showing that it's closer than 3 feet and that that's okay. Here is just like one of those worst case scenario. And so like the IRC, we're going to look at these numbers, but it allows up to 80 kilowatt hours of energy storage in an attached garage. But if you had to do those 3 feet, if they didn't do the large scale fire testing and you had to do 3 feet, you go 3, you have the width of the energy storage system itself. You have the 3 foot between each energy storage system. And pretty soon you're talking about 18 feet, 3 inches is what we have for this example. So find a garage with that much space on the wall, and you'll be really lucky to find that. And so after the large scale fire testing, we could put them closer together, of course, and then you can find places to put them on the wall. And so the energy storage system only installed in the following locations. We have detached garages, attached garages, separated from the dwelling, the living space. I'm not sure what happens when your millennial kid moves into the garage, huh? Or maybe now we have to say Generation Y. They're probably starting a $1 billion computer company, though, if that happens. And then also we could put them on the exterior walls. But if they're on the exterior walls, entering the dwelling unit, then they have to be 3 feet away from windows and doors. And so that also limits us kind of a lot here. And so here is a picture, and this came out of that SolSmart. And so here it is 3 feet away from windows and doors on the living space. But we have the detached garage. We don't have to be 3 feet away from windows and doors. There's a door right here on the outside of the detached garage. So this picture is showing us the outdoor part right here, where we can go on the outdoor. We're going to look inside coming up. And also another thing too is in the they keep changing the name of the location of the residential code for energy storage. So in 2018, it was 327, now it's 328. And maybe they did that because 327 sounded too much like an engine for a fossil fuel car of the 1970s. So here is another thing. Enclosed utility closets, basement, storage, or utility spaces within dwelling units with finished or non-combustible walls and ceilings. And then also says walls and ceilings of unfinished wood frame construction. So if it's wood, then you have to make it less combustible with sheetrock, which is gypsum. And they give us the 5/8 inch gypsum. Energy storage systems not installed in sleeping rooms or closets that open into your sleeping room. And so let's take a look here. There's a habitable attic. And so this picture here, I just wanted to mostly show it to you. Upcodes has sort of like their own informational notes, and they have artists doing diagrams like this. And so it's kind of neat there. So there's the garage. And so we're talking about the fire separation here. And this is bringing us to a different part of the residential code. So it's not specifically energy storage, sends us over to 302.6. And it's just talking about the sheetrock right here. So here's like a table that's in 302 that's telling us, how big the sheetrock has to be, attics, habitable rooms, structures supporting the floors, garages, all that. And so let's move on to here. So we're looking now at the energy ratings, and individual units shall have a maximum rating of 20 kilowatt hours right here. And so the individual units, and of course, if we did large scale fire testing, like is often done, we don't have to comply with this. And so the individual units, 20 kilowatt hours, and then the aggregate ratings of these units shall not exceed. So we could go 40 kilowatt hours and say your utility closet or basement, storage or utility space. And once again, we're looking at the IRC, so this is not commercial. And then what we have here is 80 kilowatt hours in attached or detached garages, 80 kilowatt hours on exterior walls, and 80 kilowatt hours outdoors on the ground. And so at first you might say like, well, what if I'm a billionaire? Why can't I do this? And so of course you could do large scale fire testing, go by the International Fire Code, section 1207, and you can put a megawatt battery there, just like utility scale. But also one thing that's kind of clever here is you could put 40 kilowatt hours in your utility closet, 80 in your detached garage, 80 on your exterior walls, and then 80 outdoors on the ground. So you can just start adding them up. So that would be 270, 310. So you could put 310 kilowatt hours. That should be plenty. I think it's still best to just keep it inside of your car. And then here is just some more looking into it a little bit more as far as, within the utility closets and the sheetrock and how to do, sheetrock is gypsum, how to make it so it's a little bit less flammable if there's wood framing and stuff like that. And then here's the attached garages. And so the garage space separate from the living space, certain amount of gypsum. Some of these older homes don't have the separation, so sheetrock might need to be installed. And here we have detached garages, and the difference between attached garages and detached garages is there's no drywall requirement. And then we have exterior walls, so outside of your house, and then you have to keep it away from the doors and the windows, like I was saying. And then outdoors on the ground. So this one, of course, let's see, we could go up to 80 kilowatt hours. You still want to keep it 3 feet. You still want to keep it away from the doors and the windows, but if it's outside on the ground, what are you going to do? Put it right in front of the window anyway? It sounds kind of silly. And here is what we were just looking at, except for this one part at the end. So it says installations exceeding the permitted individual or aggregate ratings shall be permitted in accordance with the IFC, the International Fire Code. And so here is the International Fire Code. We can see here too, if we look at the lithium ion batteries, we have kind of a similar table of 20 kilowatt hours here, but let's see, energy storage system exceeding these values shall comply with this section. So actually saying if it's less than 20 kilowatt hours, you don't have to do the IFC. So construction documents. So there's all this documentation that you need to do. Let's see, not specifically identified. So there's also hazard mitigation analysis that can be done. And that's also known as failure modes and effects analysis. And this is usually for larger utility scale types of battery systems that we're talking about here that you usually see. But if you wanted to, have a big battery at your house, these are some of the things that you can deal with. And, just as far as time running low, I'm going to go kind of fast through this stuff. And then when we do the questions and answers, we can go back and we can talk about this, because I think at the top of this hour, I'm not sure if we're going to get much into Article 705 too, but we can always do questions and answers, and that will take us there, whatever you want to do. So let's see, there's the IFC and the IRC are also maintenance codes. So there's a lot about commissioning, operation and maintenance, ongoing inspection and testing and keeping records, decommissioning if you uninstall something. Let's see, listed according to 9540. And here's an exception is lead acid and nickel cadmium under the exclusive control of communication utilities. And so one of the things that is pretty common is the people that are making cell towers and things, they like to have these big lead acid battery banks. And they're kind of a utility themselves where they don't really need to follow the NEC under some definitions and things like that. Not a place that we need to spend a lot of time talking about. This was just something that I thought was kind of interesting. It talks about an energy storage management system. And so the first time I've ever even seen that term was here in the IFC. And so what I did here is I looked it up in their definitions, and there's all these different energy storage system definitions that you don't really see in different places. And so I thought this is kind of interesting. And a lot of it is mostly applying to larger systems. And enclosures shall be non-combustible, repairs only by qualified personnel. And if you're going to do a retrofit, you need a permit, it says right here, and not apply to lead acid. Replacements should be considered a new installation. Repurposed and reused equipment, electric vehicles shall not be reused in applications regulated by Chapter 12 unless approved by the fire code official, unless the equipment is refurbished by a battery refurbishing company approved in accordance with UL 1974. One of the things about, reusing lithium-ion batteries, the industry is growing so fast that compared to how many batteries we're making right now, compared to how many are at the end of their life, it's such a small percentage that are at the end of their life. as far as, recycling them. I think there are some places where what they're doing is they're just taking the old lithium-ion batteries and they're warehousing them and they're waiting until it's worth it to start recycling them, like when they get a better system for that. And it's kind of even similar for solar PV with recycling. It's just like we're making so much more and it has such a long lifespan that recycling isn't that big of a deal. Plus, we're not talking about toxic stuff here when we're talking about lithium-ion batteries and PV modules. Vehicle impact protection. And so what we have here is we're talking about, so we don't crash our cars into these things here. And we're going to look at some more slides coming up on this, especially when we get back to the International Residential Code. There's actually in the IFC, there's specific things about the posts. And so sometimes we call them bollards. We put them in front of things so we don't crash into them, and other barriers, parking curves and stuff like that. And then this was something I got out of UpCodes. So they're showing the different spaces, and there's the vehicle impact protection right there. Combustible storage, combustible materials. You don't store a can of gas in your energy storage room, of course. And we look out for toxic gases and things like that, hazardous systems. Some signage, and we have talked about signage in different places. Just some different wordings, though, that we have here. So if you are doing something that would comply with the IFC, like a commercial system, you might want to use this wording here. Energized electrical circuits, things like that, energy storage system, and the phone numbers. That's a new thing, too, in the 2023 NEC, is they want to see phone numbers on your labels, which is kind of interesting. So on one of your signs for the 2023 NEC, they want to see the phone number. So like, say your energy storage system, we'd have all that other information about, the short circuit current and stuff like that, but they want to see the phone number. And I guess like if something catches on fire, or if there's a problem, something starts smoking, get the expert out there too, just in case the fire department comes out and doesn't know what they're looking at.
So it wants all 5 of those. All right, I'll look at it in depth, but that's interesting. I know it'll be a couple of years.
Also, this is the wording from the IFC, which doesn't apply to residential,
Right.
but there is stuff for residential in the NEC, in the 2023 NEC, that we can look at there too. I could even pull it up. Maybe during our next break, I'll pull it up for you.
Okay.
Yeah.
Thanks.
So security of installation. So yeah, we don't want people walking in a big battery room. And so you can have things in occupied areas, but you have to follow these certain requirements, and this is once again the IFC. So we're not usually dealing with the IFC for what we're doing. Open racks, you want to keep people away from those. Walk-in units, keep people away from those. Maximum allowable quantities of electrochemical, we have 600 kilowatt hours there, and that would be for the IFC. And size and separation, segregated into groups not exceeding 50 kilowatt hours. Each group shall be separated 3 feet from other groups. And then let's not worry about lead acid. And then the fire code official can authorize larger capacities or smaller separation distances. And once again, IFC, so we're not at the IRC. Exception to these maximum allowable quantities. So that would be approved by the fire code official right there, or dedicated use buildings. So if you had a building just for energy storage, something like that. The way that I like large scale energy storage the best is lots of containers outside. If you get a fire inside of a building, you might ruin $1 million worth of batteries or $10 million worth of batteries. Whereas if you just had them in separate containers that are spaced out in a field, then you're going to only take down a container full at once. There's elevation. And so this has to do ESS not located in the following areas where the floor is located more than 75 feet above the lowest level of fire department vehicle access. And so I believe that has to do with, your fire truck ladders and how high they can get somebody, 75 feet, and where the floor is located below the level of exit. And then there's some exceptions that we have here, like if you are friends with the fire code official and lead acid batteries and things like that. And then we, of course, have automatic fire suppression systems, such as sprinklers, things like that, fire extinguishing systems. Maximum enclosure size. So I believe this would be like a container, 53 by 8 by 9.5 feet. Sounds like a real long container, or maybe a container with some things attached to it. And separation, no less than 10 feet, but we can overrule that with a fire code official. 10 feet sounds like a good number to me. And so we could see just for lithium ion, explosion control, thermal runaway, and a lot of this stuff too is going to be done with the 9540A fire testing, exhaust ventilation, talking about gas detection. Some of this stuff I think is like, there it is, 9540A again, has a lot to do with, these big giant utility scales energy storage systems. Another thing too is since that fire that they had at APS, that's Arizona, they started making a lot of these so they're not walk-in containers, but you access everything from the outside. It's still a container, but you have doors from the outside where you get to things. And also that kind of gives you more room on the inside if you don't have to have a walking space and separation of things inside. So clearance, lot lines, and all that kind of stuff, 10 feet from buildings with exceptions, reduced to 3 feet in certain places. Exterior walls, installations, we kind of talked about. Some of these things are similar to the IRC, and so let's get back to the IRC. We need to do things, of course, with NFPA 70, which is the NEC, and with interactive inverters have to be listed to UL 1741, very basic, obvious thing that you see all over through the NEC. This is where it says we do need to have things 9540 listed, is what it says. However, if somebody is trying to do a big lead acid system, I wouldn't be personally against it. But if you wanted to be really strict with the code, there's no 9540 lead acid battery. So you could give somebody a hard time. So fire detection, so there's requirements for smoke alarms. And in some cases, a smoke alarm won't do it because it's like a hot place, like a non-air conditioned garage. And so they would need to have a heat detector. So here's just, it takes us to the IRC for smoke alarms here. And so we're going to talk more about the vehicle impact protection. And so one thing, this is in the SolSmart guidelines, but it's not part of the code. But if you're going to drive your car into a garage, the dangerous part is not the sidewalls, but going in too fast, like right in front of the car. So you wouldn't need to have any protection if you kept it over 4 feet high, because most cars aren't going to be that big, or it's going to be over 4 feet where you're going to smash into something. But if it was below 4 feet, SolSmart is recommending a curb, parking curb, or a bollard like a post. So what we can see here is the good idea is right there. So keep it up over 4 feet. These are places where we can put our energy storage system, but we want to protect it. And we don't need to protect it from the side. You still might ding it, but you just wouldn't hit it with as much force. And a lot of this stuff too is related to like putting other appliances in your garage, like a hot water heater, kind of think of it like that. You don't want to smash into one of those also. And so what we have here for the bright color right there is we've got places where you can install your energy storage system in a garage. So, of course, you're not going to install it in front of the window. Ventilation is for things that can produce hydrogen. And so we're not going to worry about that with lithium ion batteries. That's for lead acid batteries when they say ventilation, typically. And so another thing too that was kind of interesting, it referred us to a place for hydrogen generating appliances or refueling systems. So one thing that is kind of interesting is hydrogen fuel cell cars. Maybe someday we're going to have our own fueling stations where they just bring in electricity and water and you can make hydrogen in your house. I know they're talking about doing that for airports, for like, hydrogen airplanes. And so maybe someday they'll have that in the house. So get your own electrolyzer. That's what makes hydrogen. You stick a positive and a negative into water, and off the negative comes hydrogen, off the positive comes oxygen. Electric vehicle use. This is the future. And so this is what I think is pretty exciting. And so temporary use of the occupant's EV to power a dwelling while parked in an attached garage shall comply with the vehicle manufacturer's instructions in NFPA 70. So pretty much you have to do it according to the manufacturer's instructions and the NEC. So far, the manufacturers have been not going about it right. I've even heard from people that they've taken apart Teslas, reverse engineered them, and people at work at Tesla that I've talked to say that, yeah, it's just a software update. It's pretty much just a software update. And my car that already goes from AC to DC to charge the car could go from DC to AC to support the grid. So the technology's there. They just haven't done it yet, maybe because they can sell you a car and an energy storage system, or it's just too complicated. They always blame it on the warranty, but they could always change the warranty to include how many times you cycle it up and down. But I get really excited when we talk about EV to grid. I think that's the future. We're going to have all of our cars are going to be like huge batteries, and each one of them could power our house with an air conditioner for like multiple days, probably, depending on your insulation. And now what we're looking at is documentation and labeling. So this would be manufacturer's installation instruction. You give it to the owner or post it in a conspicuous location, and then the contact information. So there a label on the installed system containing the contact information. Here it doesn't specifically say phone number, but it does in the 2023 NEC, which I'll pull up in a little bit. And there, good, we made it. That's what I wanted to do, at least to make it to 705, interconnected power production systems. And so let me just kind of say here, we go to Article 702. And if we use an automatic transfer switch, it says that we need to power the full load or have load management. And so powering the full load is not what we're going to do. We're not going to be able to power a 200 amp service with a 200 amp energy storage system or something like that. You know, we don't do that. But another thing too that they figured out is load management. One way of looking at that is your standalone inverter sort of does do load management in a way, because if it cannot supply the loads, so you turn on the whole house, the way that it does load management is it turns off the inverter. So as you know, any standalone inverter, if you try to take more power out of it than it can supply, it turns off. And so a way we can call that load management. But we just get into a tricky area here when we call something an automatic transfer switch. A manual transfer switch doesn't have to supply the whole load, and a microgrid interconnect device that we have right here doesn't need to comply with any of this in 702. Optional standby systems, we'd be going to Article 706. And then here we're looking at supply side connections, and they did do some changes in the 2023 NEC. They took out some of the extra stuff they added in 2020. Another thing though too, speaking of energy storage systems, so maybe a good reason to kind of skip over 705.11, which is supply side connections. They changed it from 705.12a to 705.11. And so that would be supply side connections. Is if you're going to do backup, you do not want to connect to the supply side, because if you do a supply side connection, you are not backing anything up. You need to be on the load side of a main service disconnect with overcurrent protection. And so that would be a load side connection. And so if you put in a microgrid interconnect device, then that is going to be the main service disconnect if it's going to be like whole house backup, like you're connecting it next to the meter. And so you're going to be on the load side of that overcurrent protection device. And so it's just, there's other tricky ways of doing supply side, of doing load side connections. Also, I found where it said the phone number.
Yeah.
So you could put your competitor's phone number, like if you're going to call after midnight, call this number.
Right.
Yeah. So here it is, identification of power sources. And then it's number 2, indicate emergency telephone numbers of any offsite entities servicing the power source systems. You know, what do? Put 911, 911. But you know what? It kind of does sound like a good idea, because if something's burning and there's somebody that's like 2 blocks away and they could just jump out of bed and be there in 5 minutes, why not? You know?
Yeah, it was interesting when I saw that. I was like, geez, we've had some installers just in relation to solar have been around for 15 years. Other installers come and go. And my concern was like, oh, you put someone down on there, then they're wasting time trying to call that individual. But
yeah, it could go either way, but
yeah,
you never know. You might work half the time. And even if they called the wrong guy, maybe every firefighter should have a sort of a volunteer solar person. And when there's a solar building burning down, they call the solar expert in town and they go over there and get to be the hero.
it's interesting. There has been some interest from fire departments on connecting with towns, their own town, to know where the solar PV systems are. I would assume battery systems going forward. There are a few through the Connecticut Fire Academy, I think, that are electricians also and firefighters. So they've taught courses on stuff. Again, more of this is solar related, but I would assume it would be picked up with the batteries, or I hope it will be.
Great. Yeah, that's always a good idea. And I think it's also important too, though, to not have somebody that's going to just go that show them a whole bunch of pictures of fires and worst case scenarios and get everybody all scared.
Right.
One time I remember giving a presentation in the Philippines, and the guy that came up before me, that's all he did. He just showed them all these fires, and the people in the audience were like, oh, now we're never going to be able to do this stuff.
Yeah. When we brought up the fire stuff to you, you were thinking the same thing. As long as like the best or most current information on it, as far as that kind of thing goes, would be great as far as like the fires and anything else related to the safety stuff.
Yep.
Cool.
Okay, so let's just take a look at this. So first of all, what we're talking about here is we're talking about connecting to a feeder. So it's not a supply side connection because there is a breaker in front of it, and you got this feeder here, and then all of a sudden you're adding an inverter, you're adding a power source. And what you have to do for the calculation here is you take the feeder breaker current plus 125% of the inverter current, and then you have two things that you can do. So the first thing that you can do is you can make sure that this portion of the feeder between the inverter connection and the loads is at least the sum of the feeder breaker plus 125% of the inverter current. And if this portion of the feeder is not, what you can do, which is probably going to be the case, is you can put overcurrent protection on this feeder. And so that feeder breaker is 100 amps. So obviously 100 amps here would protect that. And so the question that people have is, can I have like a breaker at the sub panel? Like, so a sub panel control breaker, would that work? And at first, when we came out with this, there's a big argument. We were doing the Mike Holt video, and Mike Holt and Bill Brooks were arguing about this because Bill wanted it right over here, and Mike was saying it could be over here. And so it took a few years actually to get that sorted out. So what they say now is that as long as it's within 25 feet of this connection point, it would comply with the 25-foot tap rule. So if this sub panel is within 25 feet of that connection point, then a breaker at the sub panel would work. So pretty much what it's saying is this overcurrent protection device has to be within 25 feet of that connection point, but still there are people that will interpret it where like you can have it go as far as you want, put it at the sub panel, and that's for in buildings, the 25-foot tap rule. So if you're outside, you can go as far as you want. So we did just cover taps a little bit, and so let's just kind of look at what we're dealing with here. And so the 25-foot tap rule, they have that without solar. And so if you're tapping on to a conductor, and you would have to apply that tap rule to this conductor where my mouse is there going to the inverter, and to this conductor going over here. But this conductor looks like it's pretty short. There's also a 10-foot tap rule. And so let's just see if I could explain what we're dealing with this tap rule. So I take the feeder breaker, 150 amps, and then I add that to 125% of inverter current. So that is equals 190, because 32 times 1.25 is 40. And so we've got 150 plus 40 is 190. And so what we have there is 190 amps times 1/3. 1/3 of 190 is 63 amps. So if this conductor is at least 63 amps and it's going less than 25 feet, we're good. So we could put the breaker over here. If it went 26 feet, then we would need to put overcurrent protection closer over to here. Another thing is, well, we could double check this conductor here. Usually they're not too worried about this conductor, but we would double check this here. But there's the 10-foot tap rule, and they got rid of the 10-foot tap rule, and they just all made it the same calculation as the 25-foot in the 2023 NEC. But there's a 10-foot tap rule, and so pretty much if you're going 10 feet, instead of 1/3, it only has to be 1/10, so it would be 19 amps. And so you can see that the 10-foot tap rule probably is never going to even be applied because it's just such a small amount of current. And usually you would be able to satisfy the 25-foot tap rule. And so let's look at this position here. So we've got the 150 plus the inverter current, 125% of 32 is 40. So 150 plus 40 is 190. And 1/3 of 190 is 63 amps. And if we were going here using the 25-foot tap rule, this conductor would have to be at least 63 amps, but the overcurrent protection device would only have to be 60 amps. So this conductor, before we added solar, would only have to be 60 amps. But now this conductor with solar would have had to have been 63 amps. So you can see how you're getting kind of close there in that situation. If it was the 10-foot tap rule, if it was only 10 feet or less, then this conductor would only have to be 19 amps. And obviously with a 60 amp breaker, it already has to be greater than 19 amps. And so those are the tap rules. And so it looks like I got through that one pretty quick. And you've probably seen this before. These aren't super common as much as these bus bar rules. They changed the numbering around a lot too, different versions of the code, but pretty much it's mostly the same, except for the numbering. They changed it in the 2014, 17, 2020, and 2023. They keep changing these numbers here. And so let's look at the pictures. 100% rule is you don't have to put your inverters at the opposite end of the bus bar, like the famous 120% rule. You can put them wherever you want, but you can't exceed the rating of the bus bar when you add up the main breaker plus 125% of inverter current. So this is showing the inverters right next to the main breaker. And that's okay, because when we add all these together, it's obviously less than 200 amps. And then the 120% rule, which I'd imagine you're probably all very familiar with. And what we have here is we've got the main breaker. And so we take the bus bar times 1.2. So I like using 100 amp bus bar times 1.2 is 120 amps. Subtract the 100 amp main breaker, and that leaves us 20 amps would be the largest inverter breaker that we could have, which is 125% of inverter current. So that would be a 16 amp inverter or less. That is what you could fit, and you would have to put them at opposite ends. And then there was a lot of questions about labeling that I got this morning too. And so this is one of the labels, and it's always going to be there when you're exceeding the rating of the bus bar. You might as well always put something at the opposite end, because you might want to come on later and add more things. It's probably going to be the norm, is adding more things. Just another diagram of that. It's interesting that in California, they actually, for new construction, they require you to leave an open space at the opposite end of the main breaker. So here it says, when installed in California, this must reserve for solar PV input. And so the main breaker would have been at the bottom of this bus bar. So that's how that works. And another thing too about the 120% rule that sometimes I think the wording needs to improve, even in 2023 NEC, is that you can have multiple breakers at the opposite end. If there was 4 of them, backfeed breakers, then you would put 4 at the opposite end from the main breaker. And so it doesn't have to be one breaker. Some people read the wording and it's kind of confusing. It almost sounds like it needs to be one breaker and you would have to put in a subpanel, but that's not the case. That's not the intention. We can put multiple breakers as long as they don't add up to 125% of the inverter current being more than 20% of the bus bar if the main breaker was equal to the bus bar. And so you can also, thing to look for too is if the bus bar is say 225 amps, that's a big bonus because you get 120% of 225 amps, and that gives you a lot more options. We're going to look at some neat things coming up here pretty soon. This is something that can oftentimes be used if we just read the sticker: equipment fed by multiple sources, total rating of all overcurrent devices, excluding the main, shall not exceed the ampacity of the bus bar. So that just explains what that is. I call it the sum rule. You ignore the main breaker. If the main breaker wasn't there, it wouldn't make a difference because you are protecting things in reverse. To make things less confusing, we do add the load breakers onto this calculation, and we don't do it based on 125% of inverter current. So just all the breakers can't exceed the rating of the bus bar. That's all there is to it right there. And so I like to call it the sum rule or the sum of the breakers rule. Center-fed bus bars, which you don't see as much on the East Coast, but they're kind of common in California. People spent millions of dollars replacing these things until they came up with an amendment in 2016 to the 2014 NEC. And now for residential, we can do the 120% rule on center-fed bus bars. The difference in the 2020 NEC is that you can put breakers on both sides, and before they required them all to be at the same end, which was actually worse, like from an engineering point of view. So it's even better for them to be on opposite sides. It doesn't mean you get the 140% rule by some trick or anything like that, but that's what we're dealing with there. And then this is the most commonly underutilized portion of these load side connections is you can do things under engineering supervision, such as perhaps the 200% rule. And so you just need a licensed professional electrical engineer that can figure that you can put more on the bus bar than these rules say. So if you wanted to make $100 a second, you could stamp as fast as that guy and be one of these engineers doing that, right? And then there's feed through lugs. What we have here is sometimes bus bars at the bottom of the bus bar, say the main breaker's at the top, at the bottom, they have lugs right to the bus bar. And you can connect a conductor to that, and it's sort of like an extension of the bus bar. That's the way that I look at it, is it's like an extension of the bus bar, and we don't see a whole lot of that, but you might need to put an overcurrent protection device at the bottom of those lugs in order to, get it to do more things that way. Here's something that's really awesome. They changed it to energy management systems in the 2023 NEC. It's 705.13, first came out in the 2020 NEC, called power control systems. There's not really any equipment that can do this yet, or that's common at all, but we're going to look at some diagrams for this to see how that works coming up in a second. So in Hawaii, electricity is really expensive, and solar, they have the greatest penetration of solar in the country per capita. And so a lot of times they have these all-in-one meter mains like this. And so here we're connecting to a feeder. And so we're showing if this is less than 25 feet, they don't need to do anything special when they're connecting there. They're showing 80 amps of continuous inverter current with a 100 amp bus bar. So that's kind of a neat thing to do there. They give you as much as you want. Here's another neat one that's like one of the best ways of doing things is, say somebody has a 100 amp service, is to just change the panel board out. So you've got a 100 amp main breaker on a 100 amp panel board. You switch it out for a 200 or 225 amp bus bar, and you keep that 100 amp breaker, and you are very future proof. You can plug in all your electric vehicles for the next 25 years. And all these energy storage systems and PV systems, we'll show some neat pictures of that. And if you don't like pulling out the panel board and reinstalling a new one and whatever kind of requirements there's going to be for that, what you can do here is you can bypass this panel board, which is, I think this is kind of a real neat creative one. So we're using this sum rule, the sum of the breakers rule. And so we're using this, we take all the loads out, we stick them on a sub panel. There's a 100 amp, we're going to 200 amp panel. We feed it with a 100 amp breaker. We don't have to touch any of this stuff. And then all of a sudden we've got all kinds of options there. So this is like a favorite way of being creative. They eventually came up with this sum rule for combining inverters, for AC combining. And now people are using it for stuff like this, which is pretty neat. And so here is manual transfer switch. Here is a multi-mode inverter, old style. So it's got the microgrid interconnect device inside the inverter, and we are backing up protected loads through the inverter, and we can do it with and without AC coupling. So the AC coupling is we have PV inverter or energy storage inverter coming off of this multi-mode inverter. So you have a little microgrid here. And then here's the microgrid interconnect device, and we're not backing up all the loads. There's the power control system where I was talking about 705.13. And so we can put CTs in different places, and then we can protect things without having to follow things like 705.12 with all the load side connections, 120% rule. So we can throttle things down by detecting the currents, making sure that we're not overloading this bus bar or this conductor. So we would not have to oversize this conductor because we can control all this PV and energy storage here. You can see we don't even have to put it at the opposite end of the bus bar. I just think you might as well, but you don't have to. And we can control all these currents because they're connected to this energy management system, or you can call it a power control system in 2020 NEC. And so it's all connected with these different CTs. Those are current transformers in different places. So that's 705.13. And then here we are doing it, microgrid interconnect device with whole house backup. And there's the power control system and energy management system. So those things are kind of neat. I like that. So there we go. So let's see. So now I guess we can open up the floor.
Yeah, that was great, Sean. Thanks again. It's most of it's over my head, but I really appreciate listening. So let's see. I don't see anything new in the chat, but we definitely want to open it up because the important thing here is this group will be going out inspecting as soon as new projects come in. Any discussion items that inspectors are unclear on, this is a great time to bring it up. Richard, why don't you start off? Because if you want to go either on camera or just go off mute and bring up your questions, if you could start it off.
Okay, I'm off mute. So we have some questions about what needs to be outdoors, specifically with disconnects. So I wrote a couple pieces of paper here that Bill might have sent you.
I think this is it right here, right?
Yeah,
Did you also do it, the Excel? Was that you too?
yes, that was me too as well. The Excel was where all the labeling should be.
Okay.
I feel that it's probably mostly okay. I mean, there might be some stuff I had got wrong. I'm looking at the 2017 code for this.
Yeah, and also what I thought too that would help with this is, like I said, I'm writing the PV and the NEC book, and it's going to be on the 2023 NEC. But what I want to do is compare, maybe I'll have like a table sort of like this in the book, where I compare 2020 to 2023, and then I could send it to all you to proofread it for me maybe or something. And hopefully I'll have that done in the next couple of weeks.
So for labeling, we'll just start there.
Sure. Mhm.
My reasoning is if you install it on a PV system or a battery backup system, because it's a solar system, you have to say what it is. So if it's an AC disconnect, it has to say solar AC disconnect. If it's a battery stack, it has to say this is a battery storage stack, etc. I don't see that in the code anywhere. I just think that's just the way it is.
Like, is it perhaps a utility requirement that you have?
We have a utility requirement for an AC disconnect outside.
Mm-hmm. Yep.
And because of the way that the utility company has required us to interconnect these systems now, there winds up being two AC disconnects outside. One AC disconnect goes from the solar and shuts off the solar, and the other AC disconnect shuts off the AC from the backup. Okay.
Yeah. From the energy storage system.
Yes, I can send you the Northeast Utilities backup guide if you wanted to, in your spare time, have a look at how they want us to interconnect things.
Mm-hmm. Yeah, and every utility does have their own requirements. I personally think that the utility should stick with the AC side of things because that's all that affects them. But it is very common that they want you to do things on the DC side, which doesn't affect them at all.
Right. Yeah, so I have seen sites without an ESS, an emergency shutoff switch. And I like the emergency shutoff switch when it's available because I can turn this one knob and I can cause the inverter to go off. I can cause rapid shutdown to happen. I can have the DC shut off from the DC from the batteries or whatever. Then have the main panel go dead. And that's nice, but I don't know if that's available in all cases. So which of these sources has to be shut off from the outside?
Yeah, so I mean, we do have to, for PV system, initiate rapid shutdown from, outside on 1 and 2 family dwellings.
Right.
And then also for energy storage systems, we have to be able to shut them down from the outside. And we say energy storage system, that would be the 9540 listed system, which is essentially like the AC side of an energy storage system. Does that make sense there?
Yeah, I agree with that. Did you read this other opinion document that I threw together yesterday afternoon?
So that would be the Word document, right?
Yeah.
Yeah, right here. Okay. Yep.
So is the ESS a code requirement yet?
What do you mean by a code requirement?
No, National Electrical Code requirement.
If you have an ESS, then it's definitely in the code. And so there's a difference between the energy storage system disconnect. So that would be the disconnect of the whole system. And so the energy storage system disconnect, in my opinion, would be an AC disconnect. But then there's also the question that's a little bit unclear about like what we would call like an equipment disconnect when we're looking at Article 690. Sometimes too, what I like to do is when something's not clear in 706 to look in 690 because there's a lot of similarities in there. So if we look at like the equipment disconnecting means in 690, they kind of, don't have to be load break rated if they're under 30 amps and things like that. And so we do have like an equipment disconnecting means for a PV module is just the connectors on the back of the module. It says do not open under load or not for current interrupting. Here is Article 706 2020 NEC. And so it says partitions between components when we were looking for the disconnecting means. In Article 706, it says where circuits from the input or output terminals of an energy storage system components pass through a wall, floor, or ceiling, a readily accessible disconnecting means shall be provided within the energy storage component. Fused disconnecting means or circuit breakers shall be permitted. And so I would kind of look at this one is like, let's say that for some reason you had your battery inside and your inverter outside, then you would want to be able to have a disconnecting means by the battery. Like, so that would be like a, maybe a fused DC disconnect, something like that. Because if it's DC, you're very unlikely to be using circuit breakers. It might be even debatable, since it's an equipment disconnecting means, that you could use that button like the LG Chem battery itself, because the LG Chem battery doesn't really have much in the way of a short circuit current rating because you're connected to a DC to DC converter. Like, it's not going to be currents like if you were shorting out a battery. It would be currents like if you were shorting out an inverter. It would just say, oh, we can only supply this much, 5 kilowatts, and that's it. And we're going to turn off now. Like, that's what the electronics would do.
So my understanding is that a disconnecting means is required at each battery stack or LG Chem or whatever. And a disconnect is not strictly necessary, but it's necessary at the other end where you're going to use the power.
Like on the AC side.
Yeah, well, if there's a battery inverter like SMA uses, there would be a disconnect required at that site.
Yeah. I think it's just on SMA, I think it's on it. And then also another thing is, say you're using that combination, the LG Chem and the SMA, it is listed as a system already. So SMA and LG Chem got together and they listed it as an energy storage system. And so that energy storage system listing is probably going to meet all of your requirements. And so I would like to think that that button on the LG Chem battery is a disconnecting means.
Okay.
Because, you push that button on the LG Chem battery and it turns it off. The one thing about it is it's not a system disconnecting means like the one on the power wall, because it's not lockable. So if you wanted the AC disconnect, that one should be lockable.
Right.
It's like maybe they should just make it lockable, make it easier.
So outdoors, we should have a AC disconnect for the solar, an AC disconnect for whatever converts the battery power into AC. So there should be 2 AC disconnects outside.
Yep.
And we don't have to have a disconnect outside for the batteries, that we can rely on a plaque or directory to send them into the house or residence or whatever to shut off the DC.
Most of the language in 706 is for the energy storage system. And so they kind of look at it like the batteries and the inverter are all the same thing in a way, like that's the energy storage system. And so if you kind of look at that and you turn off the inverter, the way that it's listed and made to work, if you turn off the inverter, you're not going to have dangerous currents coming off of the battery there. I believe that it's going to be inside of that UL 9540 listing, that once you turn off the inverter, it signals that battery to not just have, 400 volts coming at you. And that would be 400 volts approximately. A lot of times these batteries are around 400 volts, whereas it is going through a DC to DC converter.
So here's the scenario that we're concerned about. For example, let's say you have a Generac where there is one line that feeds the Generac that just goes to the grid, and that normally is that one's that normally runs and is normally on. But you have a second AC output off the inverter that just goes to your backup loads.
Mm-hmm.
All right. So if I, for example, threw the AC disconnect outside, then the other inverter, the other source would kick on and start putting power into the house. And the first responders are pretty sure that they've shut off the solar, but it's not, because there's still power to the main panel or the backup panel.
Yeah, so what you need there, let's see, 1 and 2 family dwellings, a disconnecting means or its remote control shall be located readily accessible outside of the building. So in that case, you were talking about, a multi-mode inverter. So you need to be able to have a disconnect for that standalone portion of the system outside of the building. And you can also find that in 710 too, or if you went over here, talked about identification of power sources, but you would treat it like a standalone system too. You have to comply with 706 and 710. Maybe the best place to look at it was where we just were over here. And so that's pretty much what you have. There are some people that have energy storage systems without backup. And so just like any PV system, you should be able to program it so you can turn it off just when the whole service turns down. So like with PV without energy storage, without backup, you typically turn off the main breaker of the house. That could actually, the main breaker could be your rapid shutdown switch. You turn off the main breaker to the house and it would just make all the interactive inverters anti-island instantly. And it could also make your energy storage system inverter anti-island instantly if you are not doing backup. It's the tricky part is when you have backup. And then with backup, you need to have the energy storage system disconnect. Like here, and it says 1 and 2 family dwellings, disconnecting means or its remote shall be located readily accessible outside the building. Does that clarify that?
Yeah.
Real quick, Jeff Fuller had his hand up. I just wanted to make sure if he had a follow-up thought or a comment on it.
No, I agree with Sean. I think in the case where you're having the battery backup, there needs to be some type of remote actuation, remote EPO button, emergency power off button that's lockable to isolate the battery storage from the backup loads. Again, if there's an emergency situation, the fire department's out there pulling disconnects, they need to know that they're shutting all the power sources off in the building. And to me, that remote disconnect is a required means.
Yeah, and like if you had your energy storage system outside, that's even easier because you just turn it off right there, like your inverter. You're less likely to have your batteries outside. Probably a good idea, especially lithium ion doesn't work too well when it's snowing.
Richard, does that get to your, because I know that this was one of your bigger concerns. Does that?
Yeah, this is one of my bigger concerns. I'm pretty close to getting my head around it all.
Yeah, it is pretty complicated and it's not exactly clear. It's all kind of new stuff and it's evolving so fast.
So Neil had a couple questions.
Yeah, I just had, these would probably be pretty easy for you. I had a question on critical loads panels. Is that a requirement in the code anywhere? Or is that like a best general practice? Because I can see in some cases a contractor might not have space to put in a critical loads panel, or it might be too expensive, or is there an instance where that would be acceptable?
Yeah, so the only reason you need a critical loads panel is if you want to back something up. Like a lot of times the context that we put that in is if you have backed up loads and non-backed up loads. So your backed up loads are your critical loads. And so that would be your critical load panel. But sometimes we do whole house backup. And that especially works better with load shedding, which so you could turn off your real heavy loads too. But I know a lot of companies like Tesla like to back up the whole house. Maybe it's just kind of cleaner, easier thing for them to do. So I guess maybe you would consider your whole main panel board a critical loads panel if you're backing up the whole house. I guess I would look at it that way. But if you have some loads that are backed up and some loads that aren't backed up, it's the backed up loads that are considered the critical loads.
Okay, thanks. And then the other thing you mentioned in the IFC, there was something about not storing like flammable materials in the same area as a battery. Does that apply to residential too?
I think it kind of complies with common sense.
Yeah, I know. Well, I mean, if it's in a garage where there's cars or gasoline canisters.
Yeah, it does make common sense, but maybe that would just be like some of that 110/26 stuff where it's got to be 3 feet back. You're not supposed to store things within 3 feet. I mean, it is kind of hard to tell somebody not to park their car with the gas tank within 3 feet of their energy storage system that's on the wall. I don't know how you're going to do that. But the dangerous part is the car. We have to make those gas cars illegal. They're dangerous. You see them, they're fun for watching movies and watching them blow up. But, it's going to be really boring when we watch the action movie, an electric car goes over the cliff and then it starts sizzling for a couple of days. We want that big energy release all at once.
Great, thank you.
Uh-huh.
Cool. Let's see. I'm not seeing any more popping up in the chat. One thing I wanted to go over, and I think we did talk about this on the last meeting, is because this is kind of the last group meeting we have before we send out the individual inspectors again for these sites, mostly residential at this point. Any other thoughts you would have, Sean, on really what to focus on for this group to just like, okay, look, make sure you have this covered. I think we'd like to actually send you our inspection checklist so you can kind of look at it, not today, obviously, so you can review it in the near future. But any thoughts you would have to focus on for the group?
Yep. Have you seen the Soul Smart energy storage thing?
I don't think I have.
There we go. This is a really good resource. So let's see, commentary. They have a checklist themselves. So, I mean, you might want to just replace your checklist with this one. That's kind of what they made it for, because they want to make it just streamlined so it's all the same across the nation. It's all based on the same versions of the codes that you're using right now. You can see it has this checklist and everything. And I'm sure they've spent a lot of money putting this together. And so this one, let's see, there's the commentary. This is what has a lot of good information. So that last one was a checklist, but the commentary, I think this would be good to look up and study, because that's what pretty much what this is made for. And so, I mean, some of my material I got from here, like, so we were talking about, you know, how far things are separated and all that. But just also remember, like, when you read some of this stuff, that if something has, you know, been fire tested, there's a lot of ways around things. And so most things have been large scale fire tested, and you can install them in different ways that let you do more things. I guess that would be kind of my recommendation, just to study all that SoulSmart information, and then to also, you know, study all this. I know we went over a lot of material really quick, so it helps to study things over and over again.
Let's see, Jeff, you put something in the chat, but I wasn't sure if there was a question.
No, I'm good for the moment. I just actually wanted to thank Sean. I do have a 3 o'clock. I have to meet with Darren, so I apologize. I was going to head out a minute early, but thank you very much for everything.
Thanks, Jeff.
It's been
Yeah.
great. I
Thanks a
really
lot.
appreciate your time.
Well, I hope to come out there and meet you all someday.
Absolutely. Look forward to it.
Yep. Great.
Yeah.
Thanks.
Thanks, Jeff. Yeah, we're hoping for some early springtime visits from Sean. Not sure exactly how we're going to set it up yet, but we're looking to get through this meeting and then we'll start checking in for a springtime meeting with Sean. Any other questions? We got a couple minutes. Sean, I'm sure is good to stay till all the way till 3. If not, we can wrap it up. But if anyone has anything, you can just come off mute or send a chat, or if we're good, we're good.
This is Jim Williamson. Quick question. For ventilation requirements, are there any lithium ion products that define ventilation requirements, or is that strictly for other battery chemistries?
Yeah, you know, if you were doing some utility scale, big energy storage system, it might be in the installation manual and instructions and things like that. It's just not clearly written out. And so they would do this large scale fire testing, and you have a container load of batteries, or you did it inside of some big battery room. There could be, because, you know, if there's what they call a thermal runaway, which is a nice name for fire, then they have special requirements for that in those cases, but nothing like that for, you know, home energy storage or anything. That's all just specifically for lead acid batteries. And that's something that was confused at first, you know, when lithium ion batteries were super rare, and then people started installing some of them, and then the inspectors were looking at the code, and I don't know if it was like the 2008 NEC or something a long time ago, and they were saying like, oh, look, that requires ventilation for batteries. And so now it says specific for the technology, and you would read about it in the installation instructions.
Okay, that makes sense.
Still places in the 2008, I think it might be Indiana and one other place, New York City, something like that. So yeah.
All right. I don't see anything else. It seems like that's a wrap. Sean, can't thank you enough. We really enjoyed it, and we'll be looking forward to being in touch with you in the future on other trainings.
Yeah, thanks a lot,
Thanks.
Sean. I'm going to download the recording and send it out when it's ready. Probably go on like a YouTube link somewhere. And if Sean, if you could send over the slides, I could probably pass those out as well.
Yeah, he sent
I
it. You got
sent
it.
him an email. You should have
Okay.
them.
All right.
That's-
Cool.
Yeah, great. Thanks.
Okay.
All right.
Thank
Thank you,
you.
Sean.